Okay, guys, what's up? So today I'm gonna demonstrate for show and tell how to use an AWS Lambda function to execute automated backups of EC2 instances. So imagine, let's go to this graph. So this is what I wanted to achieve. You have a mother Terraform script that will execute an automated creation of an instance, and then beside or at the bottom of the Terraform script, there's a module that actually creates the Lambda function along with the CloudWatch event trigger to execute the automated or automate the execution of snapshots or backups of the volumes of the EC2. So just to get familiar with the battlefield, go here. So imagine you have, for now there's no running instance, so later we will have a running instance. And then you need to have automated snapshots of the volume of that instance or a group of instances regularly with retention. So that's what we want to achieve, automated snapshot creation with retention. So let me just acknowledge with thanks to my source, Kay Garsky, who actually published in public GitHub his Terraform script, and which I conveniently reused, not all, but I actually modified it. I modified his Lambda function Python 2.7 script to suit my needs. I basically reused some of his variable declaration parameters here. And when I forked it, it actually now looks like this. So for the file, for the directory structure, let me show you what I have. So there you go. Please confirm. Yeah, the Terraform TF state. Please ignore that. So I have a main .tf, which is the mother or the parent Terraform script. And if you look at that, let's go back to the diagram. If we look at that, this is it, the parent Terraform script, and it looks like this one. It's an ordinary Terraform script I used for some other use case, but for testing purposes, I'm using my personal AWS account for this demo. And of course, it declares the shared credentials file. I won't go into that, but just specify the profile name inside the shared credentials file. And this is a provisioner for a count, so just increase it more than one to provision more than one instances. And then the important thing here, and the meaty part, is the resource definition for the AWS instance creation. So that's the AMI, the source AMI I'm going to use, the type or the size. That's my key name, of course, security group ID, and my preferred tag. So let me tell you the first important thing to follow when we provision is actually we should have the prescribed tags. My Lambda function will actually read these tags. So you got a name, any name will do, but most importantly, you should have a backup key tag and a retention key tag. Okay, I should take due note that the backup key tag should be empty, okay, while the retention key tag should have a numerical value. The numerical value will actually what you want or what you prefer on the number of daily retained snapshots. Okay, so here for our example, for today, I specify 4 because I want 4 past days or 4 daily backups retained in my menu, in my AWS EC2 dashboard GUI. Okay, so that will be very, very important because these tags will be read by my Lambda function Python script 2.7. And second meaty part would be the module itself. So let's go back to the diagram. This is the TF module I was mentioning a few minutes back, and it is defined in the parent Terraform script as such. And as you can see, these are the module variable parameters I specified when I forked the original public Terraform module script. And if you can see, these got parameters over here, the EC2 instance tag. Yeah, it's. I will mention that later with when I describe the Python script for the Lambda function. Okay, so one important thing is here is the Terraform module makes full use of the cron expression. Okay, where's that cron expression going to be placed? You'll see later when we go back to the diagram. The CloudWatch event trigger makes full use of the cron of the AWS cron expression. So that's why we need it here. Okay. So then and there, before we execute, so I want to show you the folder structure. So we have the mother or the parent Terraform script right here, and it calls the Terraform module, which is the EBS underscore BCKUP. That is why we specified here in the module definition that the source would be the folder beside it. If your main or mother Terraform script is on that same folder, on the mother folder of your project, the parent folder of your project, now it's going to find the adjacent folder where to source the module. Okay, just to look inside, take a sneak peek inside the Terraform modules folder, and there you go. Inside, don't be surprised, there would be another, which I call a child Terraform script. Okay, the child Terraform script makes full use of executing or creating the specifics of the let's go back to the diagram of the Lambda function, the CloudWatch event trigger, and the required IAM policy and roles. So why do we need IAM policy and IAM roles? It's because without these definitions of AWS access components, the Lambda function will not be able to create a snapshot, will not be able to modify the snapshot, modify tags, and they will not be able to delete. Okay, why do we have the CloudWatch event trigger? It's because this is the time trigger, meaning it actually uses the cron expression to find the right time to execute the Lambda function. Okay, this will be the source trigger for the Lambda function. Okay, yeah, I want to explain to you briefly how the IAM policy and the IAM roles were defined. So it's basically inside the files folder under the module EBS underscore BCKUP module folder. Let me do this. Files, and there you go. Oh, those are JSON templates for the policy and the role for the Lambda function. Let me give you one example. Show you especially the Lambda policy. As you can see in the JSON template, these are the required access attributes. So the Lambda function must create a snapshot, delete the snapshot, create the tag, modify the attribute of the snapshot, and then reset the attribute. So going straight to the point, I need to show you the exact Lambda function Python 2.7 script. And here it goes. Okay, so when Terraform creates the back to the diagram, creates a Lambda function, it will actually prescribe or input the script to the Lambda function. So here are the declarations of what you want to import. Especially, most importantly, I want to emphasize it's a Boto3, okay, to manipulate AWS components. And then there's the declaration of the source configs. And then here I was mentioning the EC2 underscore instance underscore tag, all caps, wherein this is a declaration of where it will pull the values of the variables that are declared in your mother or your parent Terraform script. And then because it's a Boto3, it makes convenient use of filters. Okay, so how for those of us new in Boto3 and AWS Lambda scripting, the script actually reads the whole list of AWS EC2 instances in your account list, and then uses the filter parameter or the filter declaration to find based on tags. So when it finds tag key with the specific values that you want, it will execute what you want. Okay. So there. That's for the EC2 instance tag. Now, for retention, I need to mention is that once it finds and there's a retention, there's what we call the tag for retention days. And then retention days actually makes use of or manipulates what we call a delete date function, whereas the retention days is the number is equal to the number of days we specified if we go back to the parent Terraform script. This is it. It gets the retention. This tag and the value actually influences the value for retention days. Okay. So if you specify the days equals 4, because I specified in the mother Terraform script that I need the tag value of retention to be equal to 4. Okay, so that's it. So let's fire away and execute the Terraform script to create these components. Okay, so first we go to the parent directory and do a Terraform init just to make sure that we have the right plugins for Terraform. Okay, we have the right plugins for Terraform, and then we need to do Terraform plan just to see what it will create to the components due for creation. And just to get back to my AWS personal account to give you evidence that for now there's 0 instances and 0 snapshots for validation that something will be created later. And then after plan, Terraform apply. Okay, before we hit yes, let's go back to the plan. So here it's going to create the CloudWatch event. Okay, the target, the Lambda, and then there's the role and the policy. Okay, the Lambda role and the Lambda policy. Okay, cool. And of course, it will forget the instance resource definition because it will create one instance. And then let's put in the value of yes, and then the script will create the instance. Will execute based on the Terraform module to create the components, these components. Okay, so let's go back to the terminal. Just wait a bit over there. Okay, so we're done with executing the parent or the mother Terraform script. Now let us go back and refresh into my personal AWS account dashboard. Just hit refresh over there. So we should be expecting 1 running instance. Okay, very good. We have 1 running instance already from 0 and 0 snapshots for now because the Lambda function has not executed yet. It's still waiting for schedule. So let's validate. We should be expecting a Lambda function to be created, right? Based on the diagram of our script, of our project. Oh yeah, so we clicked on the Lambda function menu and we found this one. It was created like 59 seconds ago. Okay, just for validation. A minute ago. Okay, so let's click on that to see the specifics, and it brings you to a beautiful Lambda function designer view. Okay, so this is very interesting. So it actually visualizes, helps you visualize the Lambda function. On the left side would be the triggers, which is the CloudWatch events, and on the right side would be the targets or the tasks. So if we just concentrate on this first, we could see the specific Bodo 3 script of Python 2.7 that I specified, that I did, and I reused, and I modified for our purposes. So see, the Python script I described a few minutes back is basically imported as a Lambda function when it was created here. Okay, here we go. And then one important thing to note is that beside the Python script is a definition of a vars.ini file, wherein if you see the content of the vars.ini file, these are the parameter declarations in the parent Terraform script. Just want to show it's basically this. its parent Terraform script definition of the module parameters or variables are actually defined in the vars.ini. Okay, so yeah, let's go back to Python and let's go back to the designer view. So the CloudWatch events is the source on the left. So let's take a look at how that looks like. So let's click on it. Conveniently located link in the designer view, and it brings us to the rules. Okay, if you could see here, you have a list of triggers already, scheduled triggers. So my current time is 9:17 a.m. GMT plus 8. So the next trigger would be 1:30 a.m. GMT. So on my time, that's going to be 9:30 a.m. GMT plus 8. So what we're going to do is we're going to wait. I'm going to pause the recording and wait for that exact time before we resume. Okay, guys. So on my time, it's 9:29 a.m. So it's a minute, less than a minute before the scheduled trigger of our CloudWatch event trigger. So once we hit that, we're gonna see the logs just to prove that we're there and we have a working Lambda function. And while waiting for a few seconds, let's just go back to the diagram for review. So there we have a CloudWatch event trigger, which will trigger the Lambda function. And the Lambda function, of course, needs these IAM policy and IAM rules for it to proceed. So now it's 9:30. Best practice to check is actually go to your EC2 instance dashboard for now and see if we have a new snapshot. Okay, ooh, this got two snapshots over here. Okay, so one is completed and one is pending. So if, as you can see, I think that's an old snapshot, 9:15. So upon creation, it actually created a new snapshot. So here, at my 9:30 a.m., the script freshly executed and created a snapshot. So just to point to you, lastly, the logs that prove that there are traces of the script functioning is we go back to the Lambda function, okay, and go to the Lambda function itself. And when we go here to CloudWatch events, not the logs, just the CloudWatch events. And when we go back to the CloudWatch itself, let's go to the logs. And here the Lambda logs itself, and there's one. Oh, it's not yet done because it doesn't have a log yet because it's not done for 9:30. So once we see something done it's now done. So we just refresh. It should have a new log entry for 9:30. 9:15. Let's see if it's just the. Okay, we have. Oh, it's 1:30 GMT. So from here, 1:30 GMT, we could see that the script had log traces. Found one instance that need backing up. Found specific EBS volumes, and tagged it for retention and deleted the old. Okay, so basically that's how we demystified the Lambda function by having a use case of using a Python 2.7 Boto 3 script for Lambda function to be triggered by CloudWatch event rule, cron expression to create automated snapshots or backups of the EC2.